All right, we're going to get started. It is 3 p.m. Eastern Time. Welcome to AdvanceKentucky's AP Statistics Mock Exam Scoring Session. My name is Aaron Timmons. I'm the Mathematics Content Director. I'm joined by my co-host, Sherry McGuffin, who is our STEM coordinator. And we are very excited to have our presenters for today, Reva Slone, AP exam reader and MZ consultant from Johnson Central High School, and Dr. Rachel Rosales from Apollo High School in Owensboro. So both exam readers, both are super excited to be here and ready to share their knowledge with you. So just go over a couple items here before we begin. Make sure you have the handouts for today, bit.ly/mock exam 2020 materials. We posted to that link after the session today as well. So while this session is intended for Kentucky teachers, we know that there are teachers from all over the United States here. So welcome to all of you. We will do everything we can to give you an opportunity to learn and interact with us. This session is designed for getting some guidance and support leading up to the AP exam. AP is not is a trademark of the College Board, which is not affiliated with us. Neither is ETS. So Rachel and Reva are both working with their best guesses. They have no insider knowledge, as I'm sure they'll share with you. So this is our best guess. So contact information for AdvanceKentucky, Sherry, and myself can be found here. Please feel free to reach out to us with an email if you have any questions afterwards. Give us a follow on Twitter, Facebook, all of the above. Microphones will remain off for the session as well as your videos. Please leave your videos off. If you have questions, you can send any questions directly to Sherry or myself in the chat box, and we will make sure we get those questions to Reva and Rachel. So if you have scoring questions, if you have content questions, any of the above, we will make sure they answer your questions. kyap2020.com is where you can find a recording of today's session afterwards. It's also where you can find all previous recordings for our AP Statistics student content review sessions, as well as a way to register for our very last content review session on May 21st, the day before the AP exam with Bob Lachelle. So we're super excited. Last minute questions, students, teachers alike, please join us. So with that said, I'm going to stop sharing my screen and I'm going to turn it over to Reva and Rachel. Take it away.
All right, make sure I'm not muted. Let's see. So I am Rachel Rosales from Apollo High School, like you said, in Owensboro, Kentucky. And Reva, do you want to jump in and introduce yourself?
Sure. Hi, I'm Reva Slone. I teach at Johnson Central High School, as Aaron mentioned, and I am a reader. And we're excited to be here with you today. As Aaron said, just a disclaimer, we don't have any insight into the exam. This is our best guess at what you could encounter, not that that's what you will encounter, but surely these are some things that could come up.
All right, and I'm going to take us through question one. We have a couple of goals for today. We just want to make sure that we are sharing a consistent and a fair rubric for assigning scores. This is the number one thing that we learn at reading is to grade according to a rubric so that grades are consistent across the board, and then have some opportunities to practice using that so that you might be able to go and implement it with the mock exams that you administered to your students. And Reva, you just jump in anytime if you have any comments about question one as we go through it. So I'm sure you have read this question many times now if you've given the mock exam. The stem of the question, we put the goal of a nutritional study was to compare the caloric intake of adolescents living in rural areas of the United States with the caloric intake of adolescents living in urban areas of the United States. A random sample of 9th grade students from one high school in a rural area was selected. Another random sample of 9th graders from one high school in an urban area was also selected. Each student in the sample kept records of all the food he or she consumed in one day. The back-to-back stem plot below shows the number of calories of food consumed per kilogram of body weight for each student on that day. And you can see the stem plot there and our legend or key down below. And then using that stem, students were asked in part A to write a few sentences comparing the distribution of daily caloric intake of 9th grade students in the rural high school with the distribution of the daily caloric intake of 9th grade students in the urban high school. Part B asked them if it was reasonable to generalize the findings of this study to all rural and urban 9th grade students in the United States and to explain their answer. Part C said researchers who wanted to conduct a similar study are debating which of the following two plans to use. Plan 1, we can have each student in the study record all the food he or she consumed in one day. Then researchers would compare the number of calories of food consumed per kilogram of body weight for each student for that day. Or Plan 2, have each student in the study record all the food he or she consumed over the same 7-day period. The researchers would compute the average daily number of calories of food consumed per kilogram of body weight for each student during that 7-day period. Assuming that the students kept accurate records, which plan, 1 or 2, would better meet the goals of the study? Justify your answer. Part D says, assume the conditions for inference have been met. Researchers want to determine if there's a difference in the caloric intake of adolescents living in rural areas compared to adolescents living in urban areas. A test of significance will be conducted at a significance level of alpha equals 0.05 for the following hypotheses. We have our null and alternate hypotheses there, where mu1 is the true mean caloric intake of adolescents in rural schools, and mu2 is the true mean caloric intake of adolescents in urban schools. The researchers calculated the p-value of the test to be 0.000052. What does this p-value lead you to conclude? And finally, part E, describe what a type 2 error would be in the context of this study, and also describe a consequence of making this error. So what you have in front of you now is the model solution. If students were perfect and articulate and could say it clearly, this would be the primo answer. So we have the mean, which is 40.45 calories per kilogram, and the median, 41 calories per kilogram, of daily caloric intake of 9th grade students in the rural school are higher than the corresponding measures of center, which mean is 32.6 calories per kilogram, and median, 32 calories per kilogram, for 9th grade students in the urban school. There is also more variability or spread in the daily caloric intake for students in the rural school. The range was 19, the standard deviation was 6.04, the IQR is 10. Then in the daily caloric intake for students in the urban school, which has a range of 16, standard deviation of 4.67, and the IQR of 7. The shapes of the two distributions are also different. The distribution of daily caloric intake for rural students is more uniformly distributed or symmetric between 32 calories per kilogram and 51 calories per kilogram, while the distribution of daily caloric intake for urban students appears to be skewed towards the higher values. I gave this to my students, and I can tell you not a single one of them got close to the wording of the model solution. So what we want to look at are the key elements that they have to get full credit for this. All AP stats parts are scored on a rubric where they get classification of an E, a P, or an I. An E means the answer is essentially correct, P is partially correct, and I is incorrect. So the rubric for this question says we're going to score a student with an E if the response correctly compares center, shape, and spread of the two distributions. It is noted that they do not have to calculate specific values. So they do not have to find the mean, the median, the IQR, the standard deviation. They simply have to compare shape, center, and spread. If the student correctly does 2 of those 3 characteristics, they would score a P. And if the response compares none or only 1 characteristic, they would score an I. The key with comparing these things is that they do have to have those comparison words. They can't just make a list of distribution 1 and a separate list of distribution 2 and say they've compared them. So I hope you can read this. I had a hard time snipping clear writing, but this is a student response. I'll read it in case it's a little blurry. The rural distribution has a higher center than the urban distribution. The rural distribution is roughly symmetric, while the rural distribution is roughly symmetric, while the urban distribution is skewed to the bottom. The urban distribution has a larger spread, with it having a range of 19, while the urban distribution has a range of 16. So thinking about the scoring rubric, and I'll go back to that for a second so you can see it again if you don't have it in front of you. We'd like to know how you would score this student response. Would you give them an E, a P, or an I? And I think Erin is going to run a poll for you to put your responses into.
Responses are anonymous, so please, please, please participate. Also, if you have any questions, feel free to put them in the chat. Rachel, we've had some people wanting you to go back to the answer, please.
Sure, absolutely. There you go.
Also, if the polling box is in front of you, you can drag that window wherever is best for you all.
Wait just a couple more seconds. Few responses are still coming in. All right, so we'll get this out of the way. So we'll go through this piece by piece. So the first part of the rubric says that they have to, or the three components that they have to compare are shape, center, spread. And we are looking for those comparison words: higher, lower, more than, less than, greater than, smaller than, anything that indicates they've really looked at the two together. So in this response, we can see right here, we've compared the rural distribution has a higher center than the urban distribution. We have got a comparison of the shape. The rural distribution is symmetric while the urban distribution is skewed to the bottom. And then finally, we do have a comparison of spread with the ranges there. So based on the scoring guide, we think that this part of this response would score an E for having all three pieces. Okay, here's a second one to try. This is a little bit clearer, I think, to read. The stem plot shows the median number of calories of food consumed per kilogram of body weight is greater for the rural students. The mean and their ranges are greater for the rural students as well. In conclusion, the rural students appear to consume more calories of food per kilogram of weight on that particular day. So if you would like, sorry?
We had a question on the last sample.
Okay.
Is it okay to use the word bottom?
That would probably be clarified in scoring notes. I'm not a big fan of it, but I do think that it got the point of the difference and the direction of the skewness. It could be a question. It could cause them to lose that point or that check mark and drop from an E to a P. That's just clarified in scoring notes from year to year. And without any scoring notes for this particular question today, I don't know if that would be a problem or not. I chose to accept it as direction, but it could be an issue. It's probably not a great practice. I would really like the student to say something along the lines of skewed to the lower end or skewed to the smaller numbers, but I inferred bottom from that, so I chose to accept it.
All right, thanks.
All right, so we'll go back to the next one. There you go. And again, just how would you score this response?
And then another question while we leave the poll up, will this presentation, your slide deck, will that be uploaded to the folder afterwards?
Yeah, we can do that.
All right.
All right, we're about the same response rate as before. So we'll go ahead and look at it. Looks like we all pretty much agree that this would probably score a P. So let's look at the pieces that make that happen. Again, we're looking for a comparison of shape, center, and spread. So as we read through this student's response, we do have a comparison of the mean here. Their mean are greater for the rural students. We have a comparison of spread, but nowhere in this response do we see them discussing the shape and comparing the skewness of one to the uniformity or the symmetry of the other. So without any comparison of shape, this part of this question would score a P. Aaron, are there any other questions before we move to part B?
Nope.
Okay.
I think, Sherry, do you have any questions on your end?
No, we're good on this end.
All right, here we go. I'm going to be honest with you all. This is really hard to sit here and talk to an empty room and feel like you're really doing anything. So I hope that it sounds okay on your end. So 1B, the model solution says, this was the question about comparing, this was the question about generalizing. Can we generalize beyond to the United States? The model solution says no. The samples include students from only one rural and one urban high school. So it's not reasonable to generalize the findings from these two schools to all rural and urban 9th grade students in the United States. And what we find with this question is that the rubric, essentially, the students are either right or wrong. There is no middle ground. So, excuse me, you can score an E if the student has to realize that these findings cannot be generalized. And the reason is because the students were selected from only one rural and one urban high school. If the student argues for any other reason, they're scored incorrect. So if they say the results cannot be generalized, but they don't give a reason, they get an incorrect. If the students give an invalid explanation, so what I saw from a lot of my students is they focused on the sample size. Sample size is not the issue, okay? And then obviously if the student says yes, that it can be generalized, then that's gonna score them an incorrect as well. So this is a time where we see it's either right or wrong, and that happens every once in a great while depending on the type of question. So here is a student response. No, you cannot generalize the findings in this study because the sample is a very specific group, and different places in the United States may find different results and may come up with a different conclusion. So how would you rate that based on the scoring rubric? Okay, so we have most of you liked it and gave it an E. P was not an option. Remember with this particular rubric, it's basically right or it's wrong. So they would not be able to score a P. I think this is a difficult question. This was a hard one to score in my opinion. The student did mention a very specific group, but it isn't the specificity of that group that really is the big problem. The problem with the study is that they came from two high schools, one urban and one rural. So A clarification note would probably be needed to determine if saying very specific would qualify. In my opinion, as a scorer, it didn't. I needed the students to recognize that it's because it came from one particular urban and one particular rural high school.
Yeah, I will just kind of jump in and say, you know, if you've never been to the reading, you score with a elbow partner. So Rachel and I, you know, we might be elbow partners. And if you do run into a particularly challenging question to figure out, then your first line of defense is to talk to that person seated to your left or right. And then after that, if you can't reach some type of consensus, you would go to your table leader. And also there's a lot more norming to the rubric. Often we are given packets that go from sample A through sample Z. And sometimes if it's especially challenging, they'll go back and they'll do double A, double B, double C. And then there's always notes that get passed out that are board notes. So this is one of those things, it's a new question. We're just giving our best guess. And I'm sure that Rachel tied the rubric for question 1 very closely to some rubrics that have been used in previous years. And so in the absence of notes, we can just give our best judgment and roll with that. And each year the rubric team is different. And so there's different things that they'll accept or allow, decide not to accept. Even though some big themes remain consistent, there's always a little bit of variation in the rubrics as well.
And I've not made it to the level of writing a rubric. So I get, like Reva said, it's the best guess. It might work, but again, if I'm trying to train my kids and I want them to walk in and potentially maximize their score, that's what I would point out in a mock exam is, you know, be a little bit clearer. What do you mean by very specific group? All right, let's look at another sample. This student typed their work, so you can thank them for that. No, because the sample sizes were very small compared to the population size of school children in America. Also, the subject only marked their food down for a single day, which allows for bias since they could have had high or low caloric meals by chance on that day. So again, how would you score this student's response?
And before we get to that one, we have when we check conditions, we say random sampling lets you generalize to the population, but that's not the case here, is it?
Right, because we randomly selected our students from from those 2 high schools, which I don't know if they weren't randomly selected. Is that your question? I'm not sure.
Yeah, I think they want to make sure that it would not be correct to say random sampling lets you generalize to the population for checking conditions for this particular.
Right, no, that would not be correct. We
Okay.
cannot generalize to the population. Yeah.
All right, and then the other poll is coming up right now.
Okay.
Hey, Erin, I'm going to jump in again. Just while they're trying to decide on their answer to this part, it's in reference to what you and Rachel were just discussing. And I actually pulled up the question and went back and read it again, so just to make sure I'm not speaking kind of out of order here. But so they did randomly select one school. If you go back and you look at the question, one rural school and one urban school. So the question is, what is your population? And so we selected this sample from the population of interest. And if we selected students only from one rural high school and from one urban high school, then we could only generalize back to those 2 high schools. We couldn't generalize to all. And when you fast forward and you look at question B or part B of the question, it says, is it reasonable to generalize to all rural and urban 9th grade students in the US? So I think that it's important to point out for the teacher who was asking, we could generalize back to students at these 2 schools, but that would be our population since that's who our sample is taken from. It was a random sample, but that's not what Part B is asking. Part B is getting at what is the actual population, in my opinion anyway, and Rachel may want to speak to that just a little bit more. I just wanted to throw that out there.
No, I think that's good. I appreciate you clarifying that.
Sure.
All right, I think we have
some results.
Yeah, all right, here we go. So we're looking at 1B, and the student said no, but the issue with this, again, is that we only used one urban and one rural high school. The sample size is not part of the issue with this question, and so they wouldn't get any credit for saying that. So this student would score an I, and I would remind you, there's no P's on this one. It's either right or it's wrong. Okay. Any questions on that one?
Just a quick question, throwing back to Part A. And it's in terms of the comparison. If a student stated the values are high, let's see. Do students directly need to state that values are higher or lower compared to each other? For instance, if a student says the mean of one school is X and the mean of another school is Y, but never specifically compares them by saying one is greater than or less than the other, is that still considered comparing or not?
That is not considered comparing. They have to use those, I call them ER words. If they just say, this is school A's mean and this is school B's mean, they don't get credit for that.
All right, then that was it.
All right. So we will move to Part C.
Oh, actually, sorry.
Yep.
Well, last one. What would be a scenario where we could generalize to all schools?
Where we could generalize to all schools in the United States? Well, our sample would have to be representative of the entire United States. So, say if we had sampled students from more high schools, more urban schools, maybe we took one from the Midwest and one from the Northeast and one from the Northwest. I don't know what I'm missing. Southeast and the Southwest. Then sampled students from 5 areas. We could generalize then across the United States.
Okay, thanks.
Okay, so we're looking at 1C, which is asking us to look at Plan 1 and Plan 2. And here's our model solution. Since we are assuming that students keep accurate records, Plan 2 will do a better job of comparing the daily caloric intake of adolescents living in rural areas with the daily caloric intake of adolescents living in urban areas. Both plans take body weight into account by converting to food consumed per kilogram of body weight. Plan 2 includes a 7-day period, possibly days in school and days at home on the weekend, and there are differences in caloric intake among days. It would therefore be better to average over the 7-day period rather than considering only the food consumed in one day, as is the case with Plan 1. Plan 2 would provide a more precise estimate of the average daily intake. So if we look at the rubric to score this question, the question is essentially correct if Plan 2 is chosen and a correct justification involving day-to-day variability is provided. Partially correct if Plan 2 is chosen but a weak statistical justification that includes a discussion of day-to-day variability is provided. And it's incorrect if they choose Plan 1 or if they choose Plan 2 but do not have a correct justification. There were some additional notes available for this one. So, and these are the clarifications and the conversations that Reva was talking about earlier. A correct justification had to include or indicate an understanding of what might cause systematic day-to-day variability in the difference between rural and urban students in the number of calories consumed on different days of the week. So different amounts of calories on weekday versus weekend, or school days versus not school days, not just an advantage of using a 7-day average. So they had to think about what that 7 days constituted. Why was that 7 days special? And why does it make this a better plan? That's how we get to that difference between strong justification and weak justification, to differentiate between the E's and the P's. So here's a student response. The second plan would better meet the goal of the study because it would lessen the randomness of what the subjects were eating. Having information from 7 days from each subject would allow for a balance of high caloric and low caloric days and allow them to even each other out. This would make the results more realistic and give the researchers a much better understanding of the goal of the study. So how would you score that response? Okay, so as expected, we are torn between E's and P's, and as I looked at this response and tried to score it, I was torn as well. The question is, do they have a strong justification or a weak justification? I felt like they differentiated that there is going to be high calorie days and low calorie days, which are going to give us better better averages to deal with, and I scored them with an E. This would be another one of those questions, though, that would have some clarification in it. I did not like the fact that the student said they would lessen the randomness of what the subjects were eating. Randomness is a pretty special word in the world of AP Stats, and you know, I was a little bothered by that. And in fact, that could, because of using that special word kind of in a strange context here, that could actually cause the student to have their score lowered. So this could be an E. He might have eked it out. But in reality, after, you know, you look at it again after some time, you know, it could very well be that that word randomness by itself would knock them down to a P. Reva, you have anything to add?
No, I think that's a good explanation. I think he would get an E as well.
Okay, sorry. I thought you were making a signal to say something.
Oh, no, I was touching my earbud. Sorry.
Oh, sorry. Misinterpreted the signals. All right. Are we ready to move on?
I don't have any questions. Sherry, do you have any questions?
None on this end. We're good.
All right. And then here's one more sample. Plan 2 would work better to compare caloric intake in rural and urban high schools because the students have more samples to average together rather than just one sample from one day. More samples create a more accurate result. So another poll, lots of polling today. Would you give this person an E, a P, or an I? So we've got students choosing Plan 2, which is a good plan to choose, but they haven't really talked about the benefits of having 7 days compared to just 1. They focused on the number of values that a student would have, and the thinking here is simply that more numbers is better. And that's not the idea here. The idea is that this sample 2 or plan 2 is better because the samples encompass an entire week, and there are things that make 2 days out of that 7-day period different than the other 5. This reading right here would say, to me, says if there had been a plan that said 5 days instead of 7, the student would have thought that that would be better as well. They're not recognizing or communicating the variability that we're looking for between what happens when you're at school versus what happens when the students are at home. And that's really the intent of the question here, is to recognize that variability that happens and make sure that that gets included into our study. Okay, moving on, if we don't have any.
We're good here.
Okay, right, and then 1D is the p-value question. Here's your model solution. Because the p-value is less than alpha equal 0.05, we reject the null hypothesis. There's convincing evidence that the mean caloric intake for the adolescents living in rural areas is different than the mean caloric intake for the adolescents living in urban areas. When we look at scoring any interpretation of a p-value in a hypothesis test, it's a pretty standard rubric. There's 3 things that you have to score an E. Number 1, you have to state that the p-value is less than the significance level, or you could simply state that the p-value is small, or they could interpret it with a correct interpretation of what that p-value means. So there has to be a statement of the p-value. There has to be context referred to somewhere in the question. And then we have to make a correct conclusion that kind of describes the evidence against the null. So we have to link that p-value to the significance level. Okay. If we do 2 of those 3 things, the student would score a P. And if they only complete 1 of them, they're going to score an I. So if we go back to that model solution, we've got a p-value less than alpha. So there's our linkage. We reject the null hypothesis. There's our statement, our decision, and then convincing evidence that we've got our context here in that final sentence. So we're looking for those 3 kind of ideas: a link, a decision, and context. And there we go. There were some additional notes to consider as you score those. If a response includes an incorrect interpretation of the p-value, then they cannot earn credit for linkage, even if they describe it as small or compare it to alpha. So if they choose to interpret what that p-value means, it has to be a correct interpretation. Excuse me. And then in their decision or in their statement, they cannot just refer back to the null and alternate or the ho and the ha. They do have to have some context talking about those rural and urban adolescents from those schools. So here's a student response. This p-value leads me to reject the ho because 0.000052 is less than 0.05. We conclude that there is enough evidence to prove that there is a difference between mean caloric intake between high schoolers in rural and urban schools. So based on that student response and thinking about the rubric that we just looked at, would you score this student with an E, a P, or an I? All right, looks like the responses have quit coming in. So we will look at this one piece by piece. We're looking for the linkage, the decision, and the context. So if we look at this question, we have rejected the hoe, so we do have a decision. We have connected the p-value to the significance level. There is one issue with this question, and I talked with Reva about it. There's a word in here that's really too strong for a statistical conclusion, and the student has thrown in the word prove. When we do a hypothesis test, we're not proving anything. We're simply finding evidence for or against the null hypothesis. So that word prove could be a problem for this student once those scoring notes roll around. It would either score an E or a P, but they might say that using that word prove, this was a great response except for that word. And if they use the word prove rather than suggest, it's too strong. And even though it should be an E, we would knock it down to a P. So that is a possibility that this student would have gotten a P for using that too strong of a language right there. So as a mock exam, I just commented back to my student, they need to stay away from prove and use the word evidence to support or suggest. But it could be an E, but I suspect, and Reva agreed, that word would probably knock it down to a P. Any questions about that one?
Good on my end.
Okay. All right, and I think we have one more of these. This p-value would lead you to reject the null hypothesis and conclude that there is a difference between the mean caloric intake of rural and urban schools. So one more chance to score this one. E, P, or I? What do you think? All right, so if we put the pieces here one at a time, we're looking for linkage, decision, context. The student rejected the null hypothesis, so there's our decision. We do have context. We talked about the difference between rural and urban schools, but at no point in this question has the student linked the p-value back to alpha or said that it was too small. Either of those would have been acceptable, but they haven't made that connection or they haven't made that communication clear. So it looks like you all pretty much agree that this would have scored a P, and that's the reason. There's the 2 checks, we're missing the linkage.
We're good.
Okay. And then finally, the last part, ask them to define and give the consequence of making a type 2 error. So again, here's our perfect response. In the context of the study, a type 2 error means failing to reject the null hypothesis that the mean caloric intake of urban adolescents is the same as the mean caloric intake of rural adolescents, when in reality, they are different. The consequence of this error is that the nutritional needs of each group are not considered independently, and one group fails to have their specific needs addressed. So when we're talking about error, there's 2 things that we really have to pay attention to here. We have to describe the error with context. So they, again, refer back to that mean caloric intake for the rural and adolescent high schools, and describe a consequence of failing to recognize the significance of that difference. When we describe the error, we have to make sure that we give both parts of that description. It's not just that I'm getting my words all twisted up here. We have to say that we failed to reject the null, but that's not our error. The error is that we failed to reject it when in fact we should not have. So we have to include both of those pieces. A partially correct response only does one of the two components listed here, and if they do neither one, then the score would be incorrect. So there are a lot of notes on this. If a student tries to provide more than one description of a type 2 error, you always score the weakest attempt. Again, referring simply back to the null and alternate or the ho and the ha does not get you context. If the description of a type 2 error is incorrect, they can still get the consequence component correct as long as it's consistent with the error that they described. So follow through, if you will, is how I think about that. If they provide more than one description of a type 2 error, they can get the consequence component correct as long as the consequence is clearly linked to one of the error descriptions and is consistent with that. If they give an incomplete description of a type 2 error, for example, only stating to fail to reject, but not going on to say when we shouldn't have or incorrectly or something of that nature, they can get the consequence component as long as it's consistent. And if they don't give a description, then they cannot get the consequence component correct. So lots of notes on this one. Here's a student sample to look at. A type 2 error would cause us to believe there is no difference. Sorry, my dog is barking. There's no difference when there is. A potential consequence of this type of error would be not providing more food to urban adolescents who need it. So thinking about that scoring guide, would we give this an E, a P, or an I? Okay, everybody's got their responses in. So let's see if we have the pieces here. Excuse me. So we have a potential consequence, not providing food to adolescents who need it. We have stated that we would believe there's no difference when there is. So we've made the decision and stated why it's incorrect. So this student's paper would score an E.
No questions on that one.
All right. And then the last one here, type 2 error is accepting a false null hypothesis, meaning that the researchers would accept null hypothesis and conclude that there is no difference in caloric intake between rural and urban schools because the end result contains 0. So last poll for this 1E, E, P, or I. Okay, and we'll move this out of the way. There we go. So we have accepted a false null hypothesis. So we've accepted a null and it's false. So there's our decision, but we did not describe a consequence of that. And so this student did part of it, but they didn't go on to do the consequence piece. So that would be a P.
All right. While we let people ask any more questions on that, there was a question about part C.
Okay.
And that was if a student wrote that 7-day averages would be less variable than 1 day's data, would that address the scorer's variability need?
If a student wrote that a 7-day
Averages,
average would be less
variable.
variable than a 1-day average. Well,
What did the note say, Rachel, on that? What was a note? Did they ask for a specific reason, or?
Where did it go? They had to indicate an understanding of why there's going to be differences in that variability. So I don't feel like saying just that 7 days would be less variable indicates why. And the note said they had to say why that systematic day-to-day collection is going to affect the variability.
Yeah, if you look at the last piece of that note, it says not just the advantage of a 7-day average. So the person who's asked that question, that's true, that's an advantage of a 7-day average, but based upon this rubric, they're saying it's insufficient just to look at that alone.
It would probably qualify them for a P because they're recognizing that there is a difference, but they're not getting down to the nitty-gritty of why there's a difference and why those 7 days really matter.
Okay. Couple more questions now on the last part.
Okay.
So, a handful of people have had concerns about saying accept. Are you allowed to say accept the null as opposed to fail to reject?
It's not great. We don't like it. It would be a clarification. Because this question is about a type 2 error, and we're really trying to get at what is a type 2 error, I kind of feel like maybe in this case they would be okay with that indication that we think we've said that the null hypothesis is true when it really isn't. The intent of this question wasn't to interpret or come to a conclusion of a hypothesis test. We did that back in part D. This is really trying to say, do you understand what a type 2 error is? So I think that in this case, accept might be okay, but again, that could be too strong of a language, or that could be some language that would cause a score to be knocked down.
I agree with Rachel, though. I think in this case, they would overlook it. If we were talking about a decision about a hypothesis test based upon a p-value, absolutely not. A student would not get credit for that. It would be counted incorrect. But especially in a question with this many parts, that's this long, we were talking last night about some of these questions, and we were laughing about how I've scored a couple of question 6s as a reader, and it seems like we overlook everything in a question 6. There's just like, oh, we'll overlook this, we'll overlook that, and you know, you just start to roll your eyes. What else are we going to overlook sometimes? But that's just how it goes. And so because this is not a decision about the test, and they're not truly saying we're going to accept the null, then I think it would be overlooked too. But we would be on the lookout for board notes. It's above our pay grade.
And then one more. Sorry, go ahead.
When you go to scoring, one of the first things that you really talk about and focus on is what is the intent of the question, and that kind of helps determine what is important and what maybe you're going to let slide in this case. And so if the intent of the question is to correctly make a decision about the hypotheses like we did back in 1D, I think accept would absolutely not be allowed. But we've already kind of assessed that in 1D, and we don't want to double ding students and count them wrong twice for the same mistake if we can avoid it sometimes. And so, yeah, again, the intent of the question kind of drives what you're really focused on and looking for.
And then one final question, and then we can move on.
Okay.
Do you think that a consequence being a false report, would that be a sufficient consequence, or do you think that would not be enough?
A false report, I'm not sure that that's really going to be a consequence. I feel like that's just kind of restating the type 2 error. It is a false report, but what are the implications of that false report? How is it going to affect the people who read it and the people who use it in the long run?
All right, that makes sense.
Yeah.
All right, and then that wrapped up the question on our end, yeah.
All right, so Reva, do you want to switch to question 2, or do we want to go through, well, my computer's frozen, there we go. Do we want to go through another practice with, I've got 2 practice papers up here for question 1. You're muted.
You can go ahead. We probably have time. I have a shorter question, so.
Okay, I wasn't
think
sure
we're
about
fine.
how long. All right, so this is a practice paper 1. You can scroll back through on your computers to the rubrics if you don't have it in front of you. This is a part A, a part B, and a part C. I don't think we can poll all 3 of them at once, so we'll just quickly do them one at a time. Probably won't give as much time on the polling for this since we've already gone through it. But this practice paper 1, we'll look at part A and think about, would you give it an E, a P, or an I? The distribution of caloric intake, there we go, of urban 9th grade students is skewed right. Meanwhile, the caloric intake of 9th grade students living in rural areas is relatively symmetric. There are more students in the urban area that have a lower caloric intake than rural. The median for the urban area is about 20 to 30, and the mean for the rural area is about 40. So give that a thought, E, P, or I.
And then Rachel, we had some people asking, are you going to give guidance on 1, 2, 3, 4?
So Reva and I talked about that, and the problem is we have no knowledge of how AP is going to do that. With only 2 questions, both of us feel that they're not going to give 2 values and come up with a 4, 3, 2, or 1 from that, but we don't know how they would, we don't know how they're going to split it up. So I did not feel qualified at all to make that judgment call and try to say this paper would be a 4, or this question would be a 4, a 3, a 2, or a 1. Maybe you all have more information on that end, but I didn't feel qualified to do that.
No, I think that everyone's in the same situation with that. So.
Yeah, my kids are asking. I wish I could tell them, but I can't even do that. All I can do is say, you need to get a lot of P's and some E's thrown in there. All right. All right, so if we look at what this student has done, remember we're looking for comparison of shape, center, spread. We've got a discussion of the shape right here, comparing skewness to symmetry. We do not really have a comparison of mean, and we don't have a comparison of spread. So this student's paper would score an I. Oops. All right, part B. So, and this question again was, can we generalize to the United States? And the student says no. because even though the students were randomly selected, we do not know how the school or the area were selected, so we can't apply it to the whole population. And I will give you a hint, there can't be a P. Okay. They had to say no, and they had to talk about that we only used one rural and one urban school. The student kind of, when you read this, they kind of lead you to think that, well, had I picked one school in a different city or a different state, that maybe it would have worked. And the problem is that we only used one urban and one rural school. So it really, even if we picked it from a different location, it's still just one school. And that's not going to let us generalize to the United States, to the whole country. And then part C, remember, was pick plan 1 or plan 2. So this student says we want to use plan 2 because the students are being studied over multiple days, which is better because more than just one day of eating affects the results. So we can quickly decide if you want to give that an E, a P, or an I. Okay. And plan 2 is being studied over multiple days, which is better. Why are the multiple days better? We haven't talked about variability at all. We've just said multiple days is better, which could simply make the student think that more is better. A bigger sample means better stuff, better results. They haven't talked about variability and certainly haven't addressed the difference between school days and non-school days, or weekends and weekdays. Part D, with a p-value of 0.00052, we reject the null hypothesis, so we can conclude that there is strong evidence the difference of caloric intake in rural schools and urban schools is statistically significant from 0. Would you give this an E, a P, or an I? Okay, so if we look at the student's response, we have a p-value of 0.00052, so we're going to reject the null. Our conclusion is that there's strong evidence of a statistically significant difference there, but we are lacking any connection to a significance level or a statement that this p-value is small. We have to have one of those two things, not just a restatement of what the p-value is. So that's what that response there is missing. And then finally, part E was our type 2 error. So this student says a type 2 error in this context is that the null hypothesis is wrong. So the difference of caloric intake between rural and urban schools is significant, but we mistakenly fail to reject it. A consequence of a type 2 error in this situation is we wouldn't do anything to make it so that the difference in caloric intake in rural and urban schools isn't significant. Some kids would continue to get fed less than others. So E, P, or I. Okay. And looking at what this student has responded. Let's see, we've got the mistakenly failed to reject it. So what we did and the fact that we shouldn't have. We've got a consequence that says kids are not going to get fed what they need to get fed. So this is a response that would score an E. All right, any questions on that student paper?
None for me. Sherry, are you good?
I had one general question that came up, and I answered it partially, but I wanted to get your perspective as well. I'd suggested earlier about using wiggle words, and so a question came up about what are some acceptable wiggle words. So I gave some suggestions, but I'd love to hear your responses as well.
Is there a particular part that we're talking about?
I don't remember exactly which part it was.
Okay.
I think it might have been A or C, but the question came up later. So anyway,
Okay.
just different wiggle words, and when it's acceptable, when it's more acceptable to use wiggle words than others.
So when I think about wiggle words, like for part A, where we're comparing distributions, we don't have any wiggle words. We definitely have to say the mean or the center is greater than or less than. When we're talking on describing a distribution, we can always, if it's mound shaped, if we're going to call it normal, we want to throw in the word approximately or roughly or kind of. And then if we're talking about, I just lost my train of thought. I'm not sure what wiggle words we would use on part C. We have to pick a plan and say why that plan is better. I don't know if that's the one we're talking about that they were referring to or not.
I think it's the difference between prove and suggest. And
Oh, gotcha.
Suggest was not as strong. So
right. Suggest, as we know, we might be wrong, and that's what those errors are all about. Prove is saying, yeah, we've established that the null hypothesis is most certainly wrong, and we don't have that because we always have to recognize that we could make a mistake. So the suggest, evidence to suggest, evidence to think that would be a much better wording as far as having wiggle room.
that's it. Thanks.
Mm-hmm.
Then one last question. Would a student who said kids getting fed less than others versus kids getting fed less than they need to, would that be graded differently?
I think it would be okay. I think they have thought through that there's going to be a consequence of making that error. And so I think that they would probably be okay in that question. The idea, the intent is just, do you recognize that making an error has consequences, and what's that consequence going to be in the long run?
Okay. All right. We are good.
Okay. So we have one more practice paper if we want to go through that one. Maybe not wait. I may not wait quite so long on the polling to close. We'll see. Question A, the distribution of the urban schools intake appears to be slightly skewed to the right with no outliers and a center around 33. The values range from 20 calories to 42 calories. The distribution of the rural students intake is more symmetric with no outliers, a center around 42, and a spread from 32 to 51 calories.
We'll go like 20 seconds on these.
Okay. I can't tell if I'm waiting too long or not. So. All right, so we think about what this student has done. It might pain us to do it, but this student scores an incomplete or an I. They've got a great description of the two different distributions, but they've not linked them together. We could basically pull this apart and turn it into two sentences, and we don't have any way to compare them or see how they compare to one another. So unfortunately, even though the student knows how to describe a distribution, they haven't compared the two distributions to each other, which was the intent of the question. Okay, part B. It's not reasonable to generalize the findings because the samples were made up of kids from only one high school. Due to food availability and income in certain regions of the US, the caloric intakes could differ from what was observed in the sample. This is either an E or an I. All right. So the conversation that I had with this student, they might be okay, but if I didn't know the prompt, it reads like they only took the students from a single high school and not from two. They might eke out an E because they might, you might be allowed to say that. In this case, they might let you assume that the student meant one high school of each type. But I did ask them to kind of be a little bit more specific there and recognize that we are comparing two high schools. We're not taking students from just one. So I felt like that was probably going to score an I. But again, it might be one of those things that they let slide and say, this is close enough. We think they understand the gist of the question, and they might actually be able to get out of there with an E. Plan 2 would be better because taking an average over 7 days would help make the data more representative. If they only recorded calories for 1 day, there's a chance the results might not be representative of what they normally eat. Would you give it an E, a P, or an I? Okay. So we're going to do 7 days because it makes the data more representative. If we only use one, then it might not be representative of what they normally eat. I would score the, oh, that's a typo. I would score that with a P. I'll change that before we post it online. They've recognized that there's going to be more representation if we use 7 days, but we haven't recognized why the 7 days in particular, what's different about them with the weekdays versus the weekends. Again, that's a typo. I'll change that before we upload it. I think that score should be a P based on the wording of the rubric. Part D, a p-value of 0.000052 leads us to reject the null hypothesis since p is less than alpha, 0.05. There's convincing evidence that the mean calorie intake for rural schools is significantly different than the mean calorie intake to kids in urban schools. E, P, or I? All righty. This is a beautiful response. We've got a p-value that's less than alpha, so we reject the null, which means there's convincing evidence that the caloric intake is different. They've tackled all 3 parts concisely, nicely, and that's a beautiful E right there. And then finally, a type 2 error would mean that the caloric intake of kids in urban and rural schools was significantly different, but the test failed to detect it, and so we conclude that they are not different. E, P, or I for this last question. Okay, excuse me. We've got what the type 2 error is that we messed up. We made the wrong decision, but we did not have a consequence of that. So this student would score a P for that part. All right, and then I am going to stop sharing and turn it over to Reva for question 2. Reva, you're muted.
Thank God for Rachel. Okay. It's so hard to remember to unmute yourself and start talking. So I did want to talk just a little bit before we get into this question about where this question came from. Both of the questions that Rachel and I have put out here for this mock exam, they come from other questions that have already been released by College Board. For example, most of this question, question 2, or several parts of this question came from 2010 Form B number 5. So if anybody wanted to go and take a look at that actual question, you could, but just sort of to give you a rundown of that question, there were 4 parts. They asked for an addition rule in part A, which we actually have in AII. No, I'm sorry. Yeah, in AII. They also used a conditional probability for part B, which we have in part 4 of A. And then they did independence as part C, which is our part B. Then for the last part of the question, for part C, we were just trying to think about where else they could go with this question. We know that the questions are going to be multi-part and they're going to incorporate things from different units throughout the statistics course. So I decided to use some type of graphical display. And if you wanted to know where the idea sort of for this thought process came from, you can see 2011. There was a segmented bar that students were expected to create when they were told that gender was independent of party for a particular township. Lawrence Township, I think, was the name of it. And they had already looked at one where there was independence and what it looked like there. Or I'm sorry, where there was not independence. So that's kind of where this question came from. Now, in thinking about the scoring, each part of that original question from 2010 was scored as E, P, or I to get that 4-point score, with the E being a 1 and a P being a 1/2. So given that this question was longer, it was a little bit challenging to come up with scoring. So part B and part C come almost identically from the questions they were taken from, but for A, I thought it was best just to give one overall score. So that being said, let's take a look at the question. And also, if you go back and look at the 2010 Form B number 5, you'll see that this table has been scaled down quite a bit to make the numbers a little bit more reasonable for students who wouldn't have calculators, but I assume that all students are going to have access to a calculator on their phone or just a basic calculator on their computer. And these numbers, if they just think about parts out of 100 when they get to the segmented bar a little bit later, it's very easy to do the division kind of in their minds. So just mental math. So the question says, an advertising agency in a large city is conducting a survey of adults to investigate whether there is an association between the highest level of education achievement and primary source for news. The company takes a random sample of 1,000 adults in the city and the results are shown in the table below. So for part A, there were 4 probabilities we asked for. I think it's kind of unlikely that we would see something as simple as part AI, but I did want to throw it in there to give a multiple part. There have been questions where they do lead them toward that independence and have them in the previous parts calculate exactly what they need to talk about independence, and that was kind of the purpose of including it, so that calculation was already there for them to pull from. So for part I, what is the probability a randomly selected adult from this sample is a college graduate? For double I, what is the probability a randomly selected adult from the sample is a college graduate or uses television as their primary news source? Part 3, what's the probability a randomly selected adult from the sample uses television as their primary news source and is a college graduate? And then in part 4, we get into the conditional probability. If an adult who uses television as their primary news source is to be selected at random from this sample, what is the probability they will be a college graduate? So I decided to approach the scoring slides just a little bit different than Rachel. So I went ahead and gave you the model solution and scoring for this part. Notice in part I, we would expect them to show us the calculation 300 out of 1,000, which is going to be 0.03. Then we're going to actually look for part 2. I'm sorry, that should be 0.3. I've got a typo on there too, don't I? We'll fix that as we go forward. 0.3, I'll remind myself to fix that on the slide. For part 2, the probability a randomly selected adult from the sample is a college graduate or uses television as their primary news source is 300 plus 436 minus 96 out of 1,000, which works out to be 0.642. For part 3, the probability that they use television as their primary news source and are a college graduate would be 96 out of 1,000 or 0.096. And then in part 4, the probability a randomly selected adult is a college graduate given they use television as their primary news source would be 96 out of 436 or 0.2202. For scoring, it's essentially correct if the response satisfies 2 components. They need all 4 probabilities correct, and fractions are acceptable. Again, given that they don't have calculators in hand, these are relatively simple calculations, but we're going to accept the fractions, and I think they normally would any year on the AP exam. And then number 2, all 4 probabilities have to show how the answer was computed. So they can't give us a naked answer and just say 0.3, 0.642, 0.096, etc. Students could earn a partial P if they compute at least 2 of the 4 probabilities correctly. So computes, I have that italicized. They do need to show the calculation for at least 2 and have the answer correct as well. Or the second way they could earn a P is to have all 4 probabilities correct, but the answers are bald. That means they're void of computation. And that's probably a little bit of a stretch to get credit for that, but I figured we would go ahead and roll with that for this question. And then it's incorrect if it doesn't satisfy either of those criteria. So let's take a look at the first sample for part A only. And go ahead and let me know if you think this student should earn an E, P, or an I.
And then while they're polling, someone asked, how many decimal places would you expect an answer to be taken to?
You know, in AP statistics, we don't really have any rule like they do in calculus. I know in calculus, the rule is 3 spaces. I try to honor that as much as I can with my students, but some of these are going to be exact. And so as long as they don't truncate and make anything like a whole number, then I'm going to be okay with 2 to 3 spaces is fine. Sometimes we need to show more to even find a significant digit. So.
And then one other question on the answer, Reva, is what was the answer to part 2's actually 0.642, because based on the table it should be 640 out of 1,000 or not?
Oh, I'm sorry. I must have hit something wrong on my calculator. I am so sorry. What did you say it should have been, Aaron?
The person here says, should it be
Oh,
640 out of 1,000?
let me double check. That may be correct. I don't have a calculator nearby. Yep, hang on one second. I hear somebody punching some buttons. I wish I'd have caught that before we had this out here. Sorry about that. So let's see, we've got the 300 correct plus 436. And then minus 96 leaves us, it does leave us at 640. So 0.640 is what we should have.
All right, thanks.
Out of
Here are the
1,000.
answers to the first poll.
Okay, sorry about that. Okay, I'm going to minimize that just a little bit. And so let's see, hopefully, I may have made a mistake myself in scoring it, but so part A is going to be correct for part I. Double I is incorrect. Also, we have the third part is incorrect. And then the last part is going to be okay. So we're going to go ahead and say that they got 2 of those parts correct. And they should have had, I've got my poll in the way, they should have had a P. So now we're going to go ahead and move on to part B. And for part B, we have when selecting an adult at random from this sample, are the events college graduate and obtains news primarily from television independent? And we want them to justify their answer. So the events are not independent. One way to establish this is to note the unconditional probability. The probability of being a college graduate is, again, that should say 0.3. But the conditional probability is 0.2202. Because these two probabilities are not equal, the events is a college graduate and obtains news primarily from television are not independent. So they're going to earn an E if they state that the events are not independent and they give a correct numerical justification based upon that table. We would want them to refer back to, and they don't have to explicitly talk about part I and part IV or anything like that, but we would want them to see the numbers explicitly, whether they call out the parts or not. They could get a partial if they state that the events are not independent and give a correct statistical justification, but numerical support is not included. And then they could get it also if they include correct and relevant calculations related to independence, but they reach an incorrect conclusion. And so we'll see if any of those play out in the examples and see if anybody earns a P. And then it's going to be incorrect if they state that the events are not independent, but the given justification is not based upon a correct probability argument. Lots of times we'll see students trying to base it on a consequence of independence rather than something that proves independence. For example, they'll try to use the probability of A times the probability of B given A is equal to the probability of A and B, and that would not be true. It's a consequence of independence, but it's not, or I'm sorry, they'll multiply the probabilities instead of showing this comparison between the conditional probability and the probability of being a college graduate. So here's sample number 1. What would you say?
And then while people are answering, here's another question for you.
Okay.
Is it necessary to say that knowing a person obtains their news from a TV lowers the probability?
I'm sorry, repeat that, Aaron. Is it necessary to say?
Is it necessary to say that knowing that a person obtains their news from a TV lowers the probability?
No, it's not necessary to say it lowers it.
Okay.
As long as they're comparing these two fractions, that's what we need to see. They need to know that these are not the same. And they need to compare correct values. So we'll give it just a couple more minutes. I'm not sure what percentage we were at as far as responses, but it looks like we may still be thinking about this one just a little bit.
I think I cut you off a little early. Those are the results on the screen. Sorry.
Oh, okay, I'm sorry. All right, so what do we think would happen here? Oh, my controls are just not cooperating at all. Give me 1 second. It's the poll keeps getting in the way, so I don't see that it's up there. Okay, so this would be incorrect. And why would it be incorrect? They have compared incorrect values here. And so they can get a P if they state the events are not independent and give a correct justification, or if they include correct and relevant calculations that reach an incorrect conclusion, and they didn't do either of those. They've compared incorrect values, and so they would get an I. For part C on this question, we asked students to complete the graph below to show the distributions of primary news source by highest level of education received. And so then we asked them, does the graph support or refute your answer to part B, and explain? So scoring looks a little detailed here, but it's really probably not as bad as it looked. I did go ahead and add values to the segmented bar and a legend. We would want to see students adding some type of a legend for what these bars represent, the different shadings. It's not necessary that they show these values. We would want to read something fairly close to that. And so the model solution would be if the events is a college graduate and obtains news primarily from television were independent, we would expect to see the same percentage of adults at each education level using TV as their primary news source. And then this would also be true for the other news sources. Since the segmented bar graph shows these conditional probabilities differ across education levels, the events college graduate and obtains news primarily from television do not appear to be independent. And this does support the answer from part B. So to get it essentially correct, the response does need to say that it supports the answer from part B, and it needs to include two components. And those components would be correct proportions for each education level. And then number two, a reasonable justification for why the graph supports the answer from B. And we have a note that a reasonable solution would make mention of the fact that primary news source should have the same frequency across education levels if the events are independent, or different if they were not independent. And then partially correct if the response says the graph supports the answer from B and includes only one of the following two components, which would be either the correct proportions or the reasonable justification. But notice, to get even as much as a P, they do need to say that there is support. It will be incorrect if the response states that the events are not independent, but the given justification, I'm sorry, that must have been, it will be incorrect if it doesn't meet the criteria for E or P. So some notes for part C: numerical probabilities are not required, so they don't have to show us the 21%, 55%, 13% as I mentioned, but if they include those, they should be correct. Also, if more than two incorrect probabilities are stated, then the response cannot be scored above a P, and we want to grade with errors from part B. For example, if the response to B states that given events were independent, then students should recognize that the graph refutes that answer. And I probably should have paused before. I got a little torn up by some of the typos I've seen here, but that's okay. Does anybody have questions before we move on?
I think just a clarification that this particular question or part, I guess, would not be on this year's exam, correct? Because of, well, students will not need to draw a graph on this year's exam.
I haven't seen that. They will not, but
I think that note came out after we had already picked our question and put it all together, because I just saw that, but it's only been in the last couple of days or so.
Okay, and I hadn't seen it. I've been too busy with other stuff that I've been working on, so I had not seen that. So that's helpful to know. Okay, so let's go ahead then and let's look at the response. And so here's the first sample. And how would you score this student's response? EP or an I? I think it's already up there on the screen. Must not have got, either I clicked too many times or it Yeah, P, great. Just take a look at it and make sure you understand why they would get a P. So some of the students' percentages were off here, and this is why they would get a P. So Aaron, we can go ahead and stop that poll since I already have the result up there. And then are there questions on this one or?
Nope, there were no questions. We're good to move to the next one.
Okay, sounds good. So I think that what we have now is just a few whole responses, but we're still going to look at it in parts. And so we have 2 full responses to go through. And so if you would go ahead and take a look at sample 2A, and we're going to score all of part A, and we're going to report whether we think there would be an E, P, or an I.
All right, so I'll put up the poll now for the first part.
Thank you.
All right, so here are the results of the first one.
Okay, so the results of the first one, there they are. And if we look at the response, we should have an E. They really did a beautiful job here. They've shown all the work and they have all the correct values. So let's go on to part B of the same sample. This was pulled from the solutions that you all had submitted. So good job to this student on part A. Go ahead and score EP or I on this part.
And just to confirm, it was announced April 28th that students will not be required to draw any graphs or images on this year's exam.
Yeah, Rachel had said she saw that too. Thank you for that. I had not seen that note, so.
All right, and here are the results.
Okay, so most of us think this student should earn an E, and surely they do. They have compared the appropriate probabilities. They showed that they are not equal, and so these events are not independent. And then we're going to go ahead and look at part C for this student. Go ahead and see if you think they should earn an E, P, or an I. So here are our responses. Overwhelmingly, we think there should be an E. And sure enough, this student earns an E. So this was a beautiful paper. All 3 E's. In a typical year, this student would earn a 4. And so we'll go ahead. We have one more sample to look at. This one also came from responses that you all submitted. I notice we don't have as many questions on this. It's a little bit more straightforward to grade when it's all numerical and not so much reading, so much open to interpretation. Pretty straightforward rubric. It's always nice to have one of those. So most of us called this one a P, and it is a P. I thought it was interesting. This student had a really good idea of what they should be doing, but there were just a couple of minor things that they forgot. So whoever has this student, just maybe point out on double I, they just forgot to subtract the intersection. And so maybe they were just kind of nervous or whatever and forgot, or maybe they just need that confirmed. That we would need to subtract the intersection. And then also on triple I, they assumed independence when they should not have. So we want to be careful and make sure the student understands where they went wrong. And then we'll also look at parts B and C. First, we'll go ahead and score part B. What do you think, EP or I? So most of us scored at an E, and they would get an E. I do want to point out one thing, and it's always really important that students make explicit comparisons. And this student really didn't make the comparison until the very last part, that 0.3 is not equal to 0.2202. And they say that they would be equal if they were independent. And so they did do a good job. I got a little nervous that they weren't going to have that piece in there. And usually there does have to be that explicit comparison. And so just be careful about that. But sure, this student should get an E on that portion. And then let's go ahead and look at part C. Okay, so here's our results. We're kind of split on this one between an E and a P, and I'm going to guess that it's about this interpretation. They did a nice job on the graph, but this student should receive a P. And they really needed to do a better job of talking about across those regions that if the events were independent, we would expect to see TB distributed the same across all of those education levels. And so if there are any questions on either of these, I only pulled 2 full samples in. I'll be happy to answer any questions. Sorry about those typos. Working on some side-by-side screens, and that probably led to some of them. The eyes are not what they used to be, so we'll be happy to take questions if you guys have any. If not, we thank you for joining us, and Aaron may want to take it back over.
Thanks, Reva. Yeah, we'll wait, Sherry or Monique or me. If we have any questions, feel free to bring those up. All right, then while we wait for any additional questions, just put up some closing comments here. The website and email addresses for all of us can be found on this screen. Please feel free to reach out to us with any questions, concerns. We'll be sure to get back to you. Handouts for today will be on that mock exam 2020 bit.ly link, as well as kyap2020.com. The recording of today's session will also be posted there. And then Reva and Rachel will upload their slides that they just presented to you on there as well. So please be sure to check back there if you have any other needs. Just a reminder, May 21st for teachers, students especially, but teachers are welcome. One more AP exam content review session for statistics with Bob Lachelle the day before the AP exam. So that would be the last minute cram session that some students may need. Bob will be answering all questions. So we welcome all of your students. Please feel free to register. Go to kyap2020.com and click on events to do so. While we wait, Sherry, do you have any questions on your side?
No, just lots of thank yous out there, and just a thank you to everyone for participating, and good luck with your students this year.
Yeah. And I think, you know, Sherry, Reva, and Rachel, they're all AP readers for statistics, would all highly encourage anyone who's not a reader to apply to be a reader. The professional development that you gain, I know from the calculus reading, but I'm sure from the stats just as much, is some of the best professional development you can get as a teacher. Reva, Rachel, would either of you like to speak to that process of applying? I know it's, you know, maybe a little bit more than what some people thought.
Silence in the room. I'm not really sure what to say. It's been a while since I applied. I know when I originally applied, we were encouraged to apply as soon as we started teaching because the waiting period was about 3 years, and now there's a question you have to answer yes or no. Have you been teaching at least 3 years? So if you have at least 3 years of experience in, you want to go on to AP Central and just apply to become a reader. You could even just Google search, become an AP reader, I'm sure, and it would come up. It's definitely a worthwhile experience, and you get valuable classroom experience that you can't get anywhere else.
Yeah, I would echo that. Sorry, I couldn't get my thing unmuted up there. The reading is where you really learn the nuances of the questions and how do you know if they would accept, prove versus suggest in a particular year, and you start to get those nuances under your belt a little bit. It's fun and it's work, but it's definitely worth it, and it definitely improves you as a classroom teacher, not just in AP, I think, but at all levels. You just improve in your ability to score and to look at what student responses are and see if they meet what they were supposed to.
Yeah, I think too, Rachel was speaking about the nuances of the rubrics, and almost every year when I go to the reading, even though we're grading a math exam, I end up feeling like I got a lesson in English about where this word has to be or what this means if you put an S on it or you don't put an S on a word, and it gets a little challenging, but you know, these are things that I never would have really known to pay attention to had I not been to the reading, so it's just a valuable experience.
Yeah. So yes, please encourage any of you all to go ahead and apply now so that you can get into this experience. So again, the Google Shared Drive is bit.ly/mockexam2020. It's right here on this screen. And then that's where all of these materials will be today. The video itself will be on the KYAP 2020 website, but yeah, you'll be able to find all that information there. All right, unless there are any other questions, we're gonna go ahead and sign off. All right, well, thank you all for joining us. Good luck to all of your students, and best of luck. See you all later.